Okay, this is latest paper, paper 5, May, June 2023, and paper 5.2. It is planning, analysis, and evaluation. So move to question number 2. So the question is, a student investigates how the volume of the gas varies with temperature. Air is trapped in a transparent cylinder of the diameter d with a movable piston as shown in the figure. The distance between the base of the cylinder and the bottom of the piston is h. The trapped air is heated by placing the cylinder in water temperature theta. The increase in temperature of the trapped air causes the pistons to move. When the piston stops moving, the value h is measured. For each value of h, the volume V of the trapped air is calculated. Experiments are repeated for the different temperature theta. It is suggested that the volume V and the theta T are related by this equation. PV is equal to YK bracket theta plus C, where K is the Boltzmann constant, and this P is the atmospheric pressure, Y and Z are the constants. Graph of V on the y-axis and theta on the x-axis. And the question is, determine the expression for the gradient and the y-intercept. So in this question, V is required at the x-axis. So in this equation, we will make V as a subject of the equation. So V is equal to YK over P theta plus Z. And then we will simplify it like this. V is equal to YK over P times theta plus YKZ over P. And then we will compare this equation with linear equation y is equal to mx plus c. So when theta is plotted at the x-axis, then this is the gradient and this is the y-intercept. So the answer for the gradient is yk over p, this is the gradient, and this, which is ykz over p, this is y-intercept. Okay, now move to this B part. The value of theta and h are given in the table. This is theta in degrees Celsius, h in millimeter, and the volume 10 power minus 5 meter cube. So we have to convert this h in meter for the calculation. The value of the d is 27.9 plus minus 0.1. The volume V is calculated by using the relationship V is equal to pi d square h over 4. So calculate and record the value of volume, 10 power minus 5 meter cube in the table, include the absolute uncertainty. So first we calculate the volume and then uncertainty. For example, V formula is, this is pi d square h divided by 4 is given here. So pi calculator value 22 by 7. And the D is given here 27.9. 27.9 into 10 power minus 3 for the meter. It's square. Multiply by the H first value, which is 62.4, but into 10 power minus 3 for the meter divided by 4. So after calculation, after using calculator, this answer is coming 3.81. Look, 27.9 in 3 significant figure, 62.4 in 3. So I wrote this in 3 significant figure, plus minus. Now, similarly, We have to calculate the next. We will use the same value, 27.9 10 power minus 3 here, but we will change this value, this one. For this, it is 62.5. So we will write here 62.5 into 10 power minus 3. And after calculation, the answer is coming 3.99. And then for this, the rest of the value will remain same. We will change this h. We will write here 68.1 into 10 power minus 3. So the next value will be 4.16. And then we will change this value and we will write 70.9 into 10 power minus 3. So the answer will be 4.33. And then we will change this 70.9 with this 73.3. So 73.3 into 10 power minus 3. This is the new h. So the answer is 4.48. And the last value is 76.1. So after using calculator, this is coming 4.65. Now we have to calculate uncertainties in V. So the formula for the uncertainty is plus minus delta V, the maximum value of V minus the average value of V. So this is the journal formula for the error, the largest value minus the average value. So these values, calculated values, are actually the average values, and we have to calculate the V maximum. So we calculate for the first. Look, V is equal to pi d square h divided by 4. So the pi again 22/7. We will use the maximum value of the d. Look, 27.9 is the average value. At the maximum, we will add this error. So 27.9 plus 0.1, it becomes 28. So 28 into 10 power minus 3 for the meter square, multiply by the maximum value of this first edge. So add the error, it becomes 62.5. So 62.5 into 10 power minus 3 for the meters divided by 4. So this is coming 3.85. So the maximum value is 3.85 into 10 power minus 5. And the minus 5 is already there at the top. So 3.85, 10 power minus 5. We have calculated this average value. Now the maximum value is 3.85, 10 power minus 5. Minus 5 is at the top in the heading of the table. So the value is 3.85. So 3.85 minus 3.81. So this is coming 0.04. And similarly, we will calculate the maximum value for the next reading. We will subtract this 4.61 from the maximum. So you will get answer 0.03. So sometimes if we put by this 3.14, this may come 0.03. So it depends on the value of the pi, whether you are using 22/7 or 3.14. So 0.03 or 0.04. And the next, we will calculate the Vmax for this value. And then we will subtract Vmax from 4.33, the same method. You will get the answer 0.04 or 0.03. It depends on the value of the pi. And the next, so this first is 0.04. Next is 0.04, 0.04. So these values are coming, but method is same. the maximum value minus the average value. So these values are the average value, and you have to calculate separately the Vmax for each and then subtract, you will get the answer. Okay, now the first error is approximately 0.03 or 0.04, second 0.03, 0.04, 0.03, 0.04, 0.04, 0.04. So suppose we take 0.03, 0.03, 0.03, 0.04, 0.04, 0.04, and move to the next. Plot the graph of V against theta, include the error bar. So move to the graph. Select the scale is already written there at the x-axis theta, at the y-axis V. So the first point is 23 degrees Celsius and 3.81. So 23 degrees Celsius. So 21, 22, 23 and 3.81. So this is the point. So put the cross. Next in the table is 35 and 3.99. So 35 at the x-axis and 3.99. This is the point. And the next is 48 and 4.16. This is 48 at the x-axis and the y-axis is 4.16. So 4.16, this is 4.1, 4.15, and this is 4.16. And the next is 62 and 4.33, 62 and 4.33. Sixty-two and 4.33, 1, 2, and 3. And the next is 73 and 4.48. 73 and 4.48. This is the point. And the last point is 88 and 4.65. 88 and 4.65. So this is the point. So the graph points are plotted. And the next is, look at this. Plot the graph for this against theta, include the error bar in V. Now, very, very important. In your table, this V has uncertainty. So we will draw all error bars on the y-axis because the V is plotted at the y-axis. So before plotting the error bars, we will calculate error scale constant of the y-axis. The formula is the number of the small boxes divided by difference of the reading. So for the y-axis, you have to take the number of the small boxes, any number. For example, we take 10 boxes, 10 small boxes. So suppose from this point to this point, so there are 10 in number. And what is the difference of the reading? 4.6 minus 4.5. This is 0.1. So your error scale constant is 100. You can take any number of the small boxes, but the answer for the error scale constant will come same. Now, this error scale constant is multiplied one by one with each error. So first point error is suppose this 0.03. So 0.03 multiplied by 100. Answer is 3. So then we will drop from this point, the first point, 3 boxes up and 3 down. 1, 2, 3. And 1, 2, 3. We will block this. This is the error bar. So the method is error scale constant, multiply by error, calculate the answer, And that answer is the number of boxes up and down from the point and then block them. Okay, now move to the next. Next error is also 0.03 approximately. Multiply by 100. Answer is coming 3. So for the next point, the error bars are also 3 boxes up and 3 boxes down. And the next point, which is the third point, again, suppose 0.03. If your point is coming 0.04, so multiply it by 100. But here I wrote this 0.03, approximately this value. So 3 boxes again, because 0.03 multiplied by error scale constant, again 3. So 3 boxes up and 3 boxes down this bar. Now move to the next. Next 3 points are 0.04 errors multiplied by 100. So it means next 3 points will have 4 boxes up or down. So 4 up and 4 down. Similarly, 4 boxes up and 4 boxes down. And for the last, this one, again, 4 boxes up and 4 boxes down. So the rule is calculate the error scale constant, multiply this error scale constant with the error, and that answer is actually the size of the error bar up and down from the point. Now the next, straight line of the best fit and the worst acceptable line mean we have to draw the 2 line. So it's easy to draw the best fit line. So we draw best fit line first by using the scale. It is similar to your paper 3 practical. Best fit line. Try to fit all points. So suppose this is the line. In the hard copy, you can draw it properly. Your line will be much better than my line, okay? So this is your best fit line, and you have to label it BFL, best fit line. Now you have to draw the worst acceptable line. So for the worst acceptable line, take 2 error bars, one at the bottom, other at the top. Suppose this is the top one and the bottom one, yes. And then either join the top of the last error bar with the foot of the first or vice versa. So suppose we take the top of the last bar and the bottom of the first bar. So this is just a minute. Yes. So you can draw the line. Okay. Now this line is labeled as worst acceptable line. Okay, after drawing this best fit line, worst fit line, you have to select 2 points for the best fit and 2 points for the worst fit. So for example, we take first the best fit. So 2 points, any 2 points. For example, we take this point, this one. And this is P1 and its coordinates 27 at the x-axis and it is 3.86 at the y-axis. Don't take table points for the best fit line. Similarly, we will take a point here. For example, this is another point, and this is P2, and this is 85 at the x-axis, and at the y-axis, it is 4.63. And then join these 2 points with dotted lines. You have to use pencil for the graph. So in examination, you have to show these lines for the working. Okay, now copy these points here for the gradient. So divide this portion into two parts. So the P1, so this P1 of the best fit is 27 and 3.85, 27 and 3.8, I think 6. And then P2, so the P2 point is 85 and 4.63. And then calculate the gradient of the best fit by using y2 minus y1 over x2 minus x1. So y2, 4.63 minus 3.86 into, look at the y-axis value, its exponent is 10 power minus 5. You can also see it at the graph, 10 power minus 5. Don't miss this prefix. So 10 power minus 5 divided by, it is 85 minus 27. Now use the calculator for the final answer. Okay, after calculation, using calculator, this is the answer for the gradient. Now move to the graph for the verse fit. So take 2 points for the verse fit. For example, we take 1 point like this, P3. For example, this is your P3 and its coordinate 25 at the x-axis and 3.8 at the y-axis. Similarly, we will take another point. The verse fit, for example, this is the point. This one. And this is at the x-axis, 88. This is your P4. It is 88 at the x-axis, and the y-axis, it is 4.7. Now you have to join these 2 points again with a dotted line like this. This working is important. We have to show P1, P2, P3, P4, their coordinates, and then we have to join them with dotted line, but with a pencil. So next we will copy these 3 points over here. So your P3, copy the coordinates. It's 25 and 3.8 and 25 and 3.8. And then P4, so it is 88 and 4.7. And then you have to calculate the gradient of your worst acceptable line, or worst fit line, y2 minus y1, x2 minus x1. So it is 4.7 minus 3.8, but we have to write the prefix, don't ignore it, and divide it by 88 minus 25. And then by using the calculator, we have to calculate the answer, and it is approximately 1.43 into 10 power minus 7. Okay. Now for the final answer of the gradient, look, this answer, which is the answer of the best fit. So this is the true answer. But we have to write uncertainty absolute. So the difference of these two answers is the uncertainty. So difference 1.43 minus 1.43 minus 1.33. So you will get 0.1. So 0.1 into 10 power minus 7. Now the final answer will be 1.33 plus minus 0.1 into 10 power minus 7. So this is the final answer for the gradient. So the best fit gradient answer is the actual answer. And the difference of two answers, best fit and the worst fit, or worst acceptable line, is the error. So this is the gradient with its uncertainty. Now, another thing here, the unit of the gradient is not required. So no need to write it, but you have to look at the unit of this. Unit of the gradient is actually the y-axis unit divided by x-axis unit. Look, y-axis unit is meter cube divided by the x-axis unit is degree Celsius. So this is the unit of gradient. But during the calculation of the gradient, we are actually subtracting one value of the theta from the other. Mean we are calculating delta theta, change of temperature. So the change of temperature can be calculated in degrees Celsius as well as, and the change of temperature in degrees Celsius is always same value in Kelvin. For example, we have two values, 1 degree Celsius and then 5 degrees Celsius. So what is the difference of these two temperature is equal to 4 degrees Celsius. But when you will convert this 1 degree into Kelvin, you will add 1 plus 273, 5 plus 273. So this is 274 and this is 278. Then the change of temperature, again 5, but 5 Kelvin. So look, sorry, this is 274 and this is 278. So the answer is again 4 Kelvin. So whether the temperature is in degree or in Kelvin, it's converted to Kelvin, the change of the temperature will remain same. That's why instead of this degree Celsius, we can also write unit meter cube per Kelvin for the gradient. So we will use according to the requirement in next parts. Okay, now move to the next part. The question is, determine the y-intercept of the line of the best fit, include the absolute uncertainty. Again, we have to calculate y-intercept for both. So first we calculate for the best fit. The equation is y is equal to mx plus c, but when we have to calculate the y-intercept, c, we can write it y minus mx. So this x and y are actually the coordinates of best fit point, and m is the gradient of the best fit. So for example, we take P1 point, which is 27 and 3.86. So y is 3.86 into 10 power minus 5 minus, and the gradient of the best fit is 1.33 into 10 power minus 7 multiplied by x coordinate of the P1, which is 27. We calculate this. Answer is coming 3.50 into 10 power plus 5. Sorry, it's minus 5. And then we have to calculate y-intercept for the verse fit. It's y minus mx. So any point of the verse fit, either P3, P4, suppose we take this P4, its y coordinate is 4.7 and the x is 88. So we use this 4.7 into 10 power minus 5 minus the gradient is the gradient of the verse fit is 1.43 into 10 power minus 7. So 1.43 10 power minus 7 multiplied by the x coordinate is 88, and after calculation it comes 3.44 into 10 power minus 5. Now, this value is the answer for the y-intercept, but the difference of these two values is the uncertainty. We calculate the difference, 3.50 and 3.44. So it is 0.06. So we will write the answer, 3.50 plus minus 0.06 into 10 power minus 5. So this is the y-intercept with error. If unit is required, then definitely y-intercept has y-axis unit, meter cube, but not required here. Now move to the next point. This can be written as like this, 3.50 plus minus 0.1 as well, because 0.06 is close to 0.1, 10 power minus 5. Both answers are correct, acceptable by the Cambridge. Now the next is use your answer to A, C3, part C4. Determine the value of yk, include. Look, in the first part, this y is appearing in the gradient. So the gradient is yk over p. So we will write here, the gradient is equal to yk over p. And first y is required. So the y is equal to gradient time p over k. So the gradient of the best fit is 1.33 into 10 power minus 7. And the pressure is given here, look, 1.01 into 10 power 5 divided by this k. This is constant. And in physics, chemistry, this is called Boltzmann constant. Its value is given 3.8 into 10 power minus 23 joules per Kelvin. Okay. So after calculation, answer of this y is coming. Okay, so answer is coming 9.73. into 10 power 20. So we will write the value here, 9.73 times 10 power 20. But question is, include the unit, okay? For the unit, look, this K is given in Kelvin, so the gradient unit, we will use meter power 3, Kelvin power minus 1. And the pressure is in Pascal. So the Pascal is kilogram, meter power minus 1, second power minus 2, divided by joule, Kelvin power minus 1. So joule is kilogram, meter square, second power minus 2, and times Kelvin power minus 1. Now, this kg, cancel with kg, second square cancel with second square, Kelvin power minus 1 cancel with Kelvin power minus 1. This meter power 3, meter power minus 1, it meter square over again meter square. So no unit for y. And then we have to calculate the value of z. Look at the second. Look, y-intercept has z, which is yk over p is y-intercept. So we will write here y-intercept is equal to YKP over, sorry, YKZ over P. And this YK over P, this one is the gradient. So C is equal to the gradient times Z. So Z is equal to your y-intercept over gradient, and your y-intercept value is coming 3.50, 10 power minus 5, and the gradient is coming 1.33 best fit into 10 power minus 7. And you have to calculate this. So use the calculator. So the answer is coming 263.2 approximately. So we will write 263. And look, this Z is added here in theta. So theta is temperature. So Z is also temperature. But we use this Kelvin in the calculation. Look, we are using Kelvin. So this is in Kelvin. If you have to change this in degrees Celsius, so definitely you can subtract 273 from it. So you will get the answer. So 263 Kelvin unit for this. Now the next is determine the percentage uncertainty in Y. So the percentage uncertainty of y. So y is calculated from the gradient, from the p and k. So y is equal to gradient times p over k. K has no uncertainty because it's a Boltzmann constant. So the percentage of y is equal to percentage of gradient plus percentage of pressure. So the percentage of gradient. So look at the gradient. It's error divided by its reading. So error is 0.1, reading is 1.33. No need to write 10 power minus 7 because both side up and down is cancelled. Plus the percentage uncertainty of the pressure, 0.01 divided by 1.01 divided by 1.01. For the percentage, we will multiply it by 100. So after calculation, it is coming 8.509. So we will write here 8.51%. This is the uncertainty. Now move to the next part. Experiment is repeated. Determine the temperature theta that give a value of the H 60 millimeter. So determine the temperature theta that gives the value of H of 60 millimeter. So according to the equation, V is equal to, it is yk over p times theta plus ykz over p. So it can be written as m times theta, mean gradient time theta plus y-intercept. Now theta is required, so we will write it volume minus y-intercept divided by gradient is theta. Now volume we will calculate with this value. So look, V is equal to 22 by 7, and this D is given here, which is 27.9. So we will write here 27.9 10 power minus 3 for the meter and multiply by H, this one, which is 60 times 10 power minus 3 for the meter divided by 4. And the answer for this is coming approximately 3.7 into 10 power minus 5. So 3.7 into 10 power minus 5 minus the y-intercept value is 3.5 into 10 power minus 5. 3.5 into 10 power minus 5 divided by your gradient, and the gradient was 1.33 into 10 power minus 7. Now you have to calculate this. After calculation, okay, after calculation, the answer is coming 15. So the answer is 15 degrees Celsius. So this is the temperature. So this is May, June 2023, paper 5-2, question number